Bismillahirrahmanirrahim. Assalamu alaikum dear students. I am Arif and I welcome you all to the next session on the subject of system programming with Linux. Well, this is a continuation of the previous session. If you have not seen or watched video lecture number 38, please watch that first and then fall back to this. Excuse me. Well, the main agenda of today's session is what are shell codes and how to create or get them. We will discuss 4 ways of doing that. First is the hardest one, but very informative, in which we will write our own shell code from scratch using assembly language. Second is the easiest one, that is getting shell code from the internet resources, but this is a bit risky as well. Third way is writing your own shell code using the pun tools. And lastly, we will use Metasploit framework msfvenom. Moreover, we will use these shell codes in a standalone C program. And in the next session, we will learn injecting these shell codes in the memory address space of vulnerable processes. So I think we have a lot to do today, so let's start playing. Well, what is a shell code? A shell code is a machine-dependent code that can be executed by the CPU directly, without the need of any compiling, assembling, or linking. The typical goal of a shell code is to create a shell, preferably with root privileges. That is why it is named as shell code. The shell code is stored in a process address space at some convenient place, which can be the code section, process stack, as shown in this figure. And inside the process stack, you can inject it as part of some input buffer, or maybe you can place it in some environment variable as well. This shell code can also be placed inside the heap. Well, after doing that, what all you need to do is to execute the shell code, and for that you need to transfer control of execution to that address space where this shell code is residing. So let us move on to the first part, in which we will learn writing our own shell codes in the assembly language. Well, these shell codes can be written in C, but better to write in assembly. And for that you must know the underlying system calls, and you should know how the dup call, the exec call, and the open read write call work. You should have a clear understanding of the architecture's function calling convention, which we have discussed in the previous session. And these are the 4 or 5 steps that you need to follow. First of all, you need to create the assembly code, then generate the object file, and from that object file you need to extract the opcodes, and you need to ensure that there are no null bytes in the assembly instruction. If there are, you must rewrite the assembly instruction. We will soon see this. Finally, the generated opcode will be extracted from the object file, and then that is the shell code, which can be used as part of a process, a standalone process, and maybe you can inject that shell code into a vulnerable program. Well, the general format of a C program using a shell code is shown over here. The shell code is placed in the process address space in a string. Inside the main function, we cast the address to this buffer named code to a function pointer named whatever. Over here I have named it foo, which is passed nothing and it returns an integer. And finally we need to call it, and that is the transferring of flow of execution to this shell code. Okay, for a proof of concept, let us move on to the Linux terminal for writing our own shell code and then using that shell code in a standalone C program. Let me show you a very basic assembly program, and we have seen such programs before as well, in the previous session as well. Over here I'm just calling the exit system call using the syscall, and you see the first argument to the exit system call is placed in the RAX register, and the system call number is placed inside the RDI register. And if you have other arguments which you sorry, I have done it other way around. RX contains the system call number, which is 60, and RDI contains the argument to the system call. And if there are other arguments which you need to pass to the system call, they can be placed in RSI, RDX, RCX, R8 and R9. Okay, let us assemble to generate the object file using NASM in the format of ELF64 exit shellcode 1.nasm, and there you go, we have got the object file. Let us see the machine code using the Objdump command, and let's see it in Intel format 1.0, and there you go. You can see this is the machine code for this instruction, this is the machine code for this instruction, and this is the machine code for syscall. Well, dear students, in case of standalone program, these null bytes inside the opcode does not make much difference. But if we are writing a shell code, it must not contain any null byte. And the reason is, when we will inject this shell code to the vulnerable program, which might be using the strcpy function to copy it in the buffer, then the strcpy function will copy only part of the shell code and not the complete shell code, because strcpy will stop when it encounters a null byte. So the solution is, we need to rewrite this assembly program in such a way that there are no null bytes in the opcode. Let's do that now. Let me copy this exit shellcode 1.nasm to exit shellcode 2.nasm. Let me open it in vim 2.nasm, and okay, so how we can change this instruction, this move instruction? Okay, we just need to place a value of 60 in RAX. So let me do that, XOR RAX to place a 0 in RAX. Then let's do a move to AL, 60, and this will do the job. And the next thing is, I need to change this instruction as well. I need to place a 0 in RDI. The easiest way is doing the XOR, and that's it. So let me try this out. Well, this code will have the same impact. Let me compile it with nasm-f elf64 exit shellcode 2.nasm to generate the object file, and let us see the machine code again. Let me use the previous command objdump for this, and there you go. You see the opcode now that do not contain any null byte. There is no null byte over here, over here, over here. Okay, the next task is, we need to extract these bytes 3, 4, 5, 6, 7, 8, 9 and 10, 11, about 11 byte machine code from here. We can do it manually, but for large shell codes we have to find some automated solution. Let me clear screen by pressing Ctrl L, and okay, let me see it again. Okay, So what I need to do is I need to only grab those lines which start with a space. I don't need this line, or this line. I just need these lines, and these lines are starting with a space. So let me pipe this output to grep. Okay, that's fine. So you see, now we only have those lines which are starting with a space. Next task is I need to do a cut. Let me shrink the size a bit. I need to do a cut. I need to cut this field. So let me again pipe this to cut -f2 with field 2, and there you go. We have our shell code over here. I think we have to now enter in a loop through these 4 lines. Let me clear screen, and let me use a loop for I in, I don't need 2 its. This output, okay. So what I need to do in every iteration, I need to do echo without a new line, prefix with this, and then a $I. I think this should work, and then that's it. And let me put a new line at the end. So there you go. So you have this shell code over here. That is great. We have finally generated a shell code that of course will perform not much task, just an exit call with a value of 0. Let me copy this, and let me show you the exit shellcode.c. This is a standalone template program that you will be using. The same we have discussed, and I just need to paste the shell code over here. That is it. I think our job is done. Let me compile this exit shellcode.c and let me execute it. And it say just the length is 10 bytes and it exits. And if I check the exit value status, and that is 0. Okay, so let me show you another example which will be displaying a line as well on the standard output. Okay, so hack planet earth 1.nasa. Well, you can see over here again we have a write system call, and the system call number is 1, which is placed in RAX, and the 3 arguments to write are placed in RDI, RSI, and RDX respectively. Then we have the exit system call. The system call number of exit is placed in 60, is in RAX, and the return value or the exit value is placed in the RDI. We have seen this code before as well. Let me compile this. nesum -f elf64 to generate the object file. Let me use Objdump -m in the Intel format -d, and let's check out the contents of this file. Great. So we have the .text section over here, and the opcode is having a lot of null bytes, and we have the data section as well. Excuse me. Okay. And we need to rewrite this assembly. Excuse me. And I have done that to save time. hackplanet2.nesum. So this is the rewritten code doing the same task, and this time you will not see any data section over here. This will dynamically figure out the address of the string, this string, using the jump call pop sequence. I'm not going to the details of the shellcode development. If you are interested, you can see videos of Vivek Ramachandran on YouTube. They are really good ones on the subject. Let's just do the extraction. Objdump -m intel -b hack planet earth 2.0. Fine. So this time you see we don't have any null bytes over here. That's great. Let me clear screen and use history to get this loop from here. I'm just trying to save time. Paste it and just change the name of the file, and that is exit shellcode. No, it is not exit shellcode, or rather this time it is hack planet earth 2.0. I think that is okay. Well, you really don't need this part, that is the format part. You can skip this, and there you go. We have the portion of shellcode that is going to perform this task. Let me copy this and let me see if I have the program with me. Hack planetearth.c. Well, yes, I already have, and I have pasted that shellcode over here. That's great. Let me do gcc hack planetearth.c, and it has generated the ./a.out executable, and that is great. So it is working perfectly fine. Check out the return value, that is 0. Okay, let us do one more thing, that is load this program in GDB and understand how the flow of execution actually transfer to our shellcode. gdb-q in quiet mode. Okay, a.out. So there you go. Let me put a break in main. Remember, we have installed PIDA, Python Exploit Development Assistance, in the previous session, and that is why we have enabled it, and we are seeing the PIDA prompt. If you want to disable it, you don't like it, you can mention it in the GDB init file. But anyway, this is a great tool. Let me run it, and you see the assembly, you see the registers, then you have the assembly over here, and you have the stack as well. Let me shrink the size a bit. Fine. Well, the procedure prologue has already executed, and this is the call to strlen that is used to calculate the length of the shellcode. Let me press ni because I don't want to enter in that. Let's keep moving ahead. This is the print statement where we are actually printing that. Let me move ahead. Now we are moving towards the shellcode. You see the instruction call rdx. We are actually moving to the starting address of a shellcode, and we are placing that address in the register rdx. And if I move one step ahead, and let's see the contents of rdx. Well, there you go. So this is the address 54788. Let me do si and let's call it. You will see that the address will be 554788, and there you go. 554788. So this is the assembly of our shellcode. Okay, so let us see the contents of memory at this location. So let me copy this address and use the examine instruction. And I know the shellcode is of 77 bytes. I want to see them in hex, and I want to see them byte by byte from this address. And there you go. This is our shellcode starting from hex EB to 0A. Let us compare this with the shellcode in our C program, list main. And you see, this is the same shellcode which we have mentioned over here. Let me press C to continue, and it says, let us hack planet Earth with Arif. Let me press Q to quit. Okay, dear students, now we have a fair idea of how to write basic shell code of our own and then test it in a standalone mode in a C program. Let us fall back to slides. Okay, so writing shellcode that performs real productive tasks might take a bit of expertise and time. So let us see if we can download ready-made shellcodes from the internet. Well, dear students, if you are a very good hacker, you always try to write your own shellcodes, and the task is not much tricky for assembly guys. The obvious drawback is that you can write shellcode for the architecture that you are working on. What if the shellcode for other architectures, you need shellcode for other architectures like ARM64, PowerPC, or maybe Android? Moreover, sometimes it becomes a bit tricky if you are not good at assembly language programming. So being newbies, the simplest option is downloading shellcode from your for your specific hardware and operating system from these internet sites. Let me visit shellstorm.org. Well, this site contains an archive for different shellcodes for different architectures. For learning purpose, you should copy these assembly codes and use them. We are interested in Linux, not ARM architecture, but we are interested in x86 Linux, NetBSD, Solaris, Windows, all these operating systems are available. And we want to check out for Intel x86-64 because this is my architecture. Let's see some shellcodes. First is, let's suppose this. Okay. Let's see this. Add user and password with open read write close by Christopher G. So this is the assembly, and this is a shellcode. This is a complete template program. You can just download it and you can use it. This is going to add a user in the system. The username will be pwnedpunt and the password is this. Let's see some other code. Let me search for a code that will spawn a shell, and that is bye TCP bind shell. Well, fine. Well, this is 27 byte execute bin sh code by that. This is again great. You can simply copy this program from here and use it, or you can copy only this shell code and use it in your program. Well, let us fall back and see what the proof of concept we have over here. To save time, I have created some sample programs for the shell codes from this site. Let me switch to this directory and let me show you the program myshell.c. Well, this is the program that I have copied from there, from this site, written by that, and this is the actual program. Let me do gcc myshell.c -o myshell. Let me run it, myshell. There you go. We have the prompt over here, and if I do, that is great. Let me press exit. Let me do one more thing. Let me change the ownership of this program to root. Sudo chown root myshell, and let me change the rather set the SUID bit. Sudo chmod set the SUID bit of this program as well. And remember, right now I am Arif, and let me execute this program, and there you go. You have a shell on this local machine with escalated permissions, with root permissions. I am root on this machine, having the IP of 192.168.100.21, and I can do whatever I feel like. And let me exit. Clear doesn't work over here. That is about the local machine. Let us use another shell code that is a port binding shell code. Let me show you the example shell bind _TCP. Well, dear students, this is the shell code. Once again, I have taken it from Shellstorm, and what this program is going to do is, once we will execute this program, it will execute on our Kali machine having this IP, and this will open a port 4444 on this machine, and anyone in the world can connect to this machine on this port. And once anyone in the world connect to this machine on this port, it will get a shell of its own. Okay, let me compile it. gcc shell bind tcp.c -o shell bind tcp, and let's execute this shell bind tcp. It is running. Let me come up onto this and let me show you the status of the sockets. Netstat -ant, and you see there is a process on this machine which is listening at port 4444. Let us now move on to Ubuntu server, which in this case will be the attacker machine. This is the victim machine. Right now I am on Ubuntu server having the IP of 192.168.100.20, and of course I must be able to ping the Kali machine 192.168.100.21, and well, yes, I can do that. Now, being an attacker, let me connect to the target machine, which is Kali in our case, using the netcat 192.168.100.21 at port 4444. I press enter, and there you go. Whatever I'm going to type over here, it will go to Kali machine, will be executed, and the output will be sent here. You see? All these commands are being executed on Kali machine. That is great. Great job done. Let's fall back to Kali. Okay, dear friends, we have seen how a bind shell work. For completeness, let me show you how a reverse shell work. This time, let me show you a C program first. Let me show you the C program in Vim, reverse shell TCP. You will be able to understand it. This program is going to run on victim machine, which this time will be Ubuntu server. Okay. A reverse shell actually creates a client socket, as shown over here, and connects to a remote listener socket that will be running on the attacker machine, that is Kali. So this will run on the victim machine, that is Ubuntu server, and this will try to connect to this machine, that is Kali, and there will be a process running on Kali which will be listening for this port, and it will try to connect. And this is where the magic is being done. This loop will do nothing other than that it will duplicate the standard descriptors, that is std in, std out, and std error, to the socket descriptor, that is this one. And after doing this, that is after setting the ppftT, it is going to call execve. So it will execute that shell program on Ubuntu server. I hope the concept is clear. If you are new at socket programming, please watch the 3 or 4 video sessions which I have taken before this part. Let me compile this program, gcc c shell with a.out. Since the victim machine this time is Ubuntu server, so let me copy this program to Ubuntu server. scp./a.out, root at 192.168.100.20, and let me copy this in the home directory of root. Let me give the password of root on Ubuntu. Let's check out over here. The program, yes, the program is here. Okay, now this Kali machine is our attacker machine, so let me run a listener process over here that listens for incoming requests from all IPs at port 54154, which is the port on which the victim machine will hit. Let me use netcat-l for listener, -p for port 54154, and in verbose mode, and there you go, it is running. Let me confirm this. netstat-ant. Oops, sorry for the typo. And well, we are listening over here. Now the Kali machine, or Kali over here, we just need to execute this program. And if I fall back, you see we have established connection. And I have a prompt over here which says whatever you are going to type is going to go to the victim machine, that is Ubuntu server, and the output will be given over here. And check out, I am root. Well, yes, that is great again. This is really fun for me. I don't know about you. Let me exit this, and this program is also exited automatically over there. So I've shown you the C program for better understanding. I've also downloaded the shell code for the reverse TCP shell as well. Let's see that as well. Vim shell reverse TCP .c. Oops. Do I have that program? Okay, yes, I do have, but with a single dot. Yes. So this is the program, and this is a shell code which I have downloaded. This program has been created using the same concept which we have seen in that C program, using the socket calls, and that is great. You can use this as well. Most of you might be thinking that how come the root user of victim machine will allow us to copy and run this malicious program on his machine? The answer to this is, of course, we will pass this shell code, that is this one, uh, as an input string to a program running on the victim machine, having a buffer overflow vulnerability. And this we will do in our next session, inshallah. The main target of today's session is just make you understand about shell codes and their usage. Well, let me quit this and let us fall back to the slides. Okay, so let us learn another way and an easy way to create our shell codes, and they are pun tools. Well, dear students, we have seen the installation and usage of PDA in the previous session, which is just a wrapper around GDB. We have used the feature of its customized view in the previous session, and today we are going to use pun tools, which is a CTF framework, capture the flag framework, and exploit development library written in Python. Well, it is designed for rapid prototyping and development and intended to make exploit writing as simple as possible. And since our main target is writing our own shell code, so we will focus on its submodule called shellcraft, which allows us to write assembly code similar to what we have done in the assembly using NESM. But this time we will be using Python. So you don't have to know much about assembly to make this work. However, you need to have a working background of Python. You can install pun tools using these commands. Soon we will see on the terminal. So let us move on to the Linux terminal and make this happen. Let me clear screen. Okay, so dear students, once again, please, for this part, I am assuming that you have a basic working knowledge of Python. On Kali, it is pre-installed. To check out the version, I can just write down Python and I can press tab twice. Oops. And there you go. I have different versions, 2.7, 3.5 and so on. And let's check out the default version. Well, the default version is 2.7. We are on the prompt. Let me press Ctrl D. And if you want to run 3.6, you can run 3.6 as well if you want to. Well, today I will be using Ipython, which is an advanced interactive Python shell having some additional features which I like. For example, the tab auto completion on class name, functions, methods, and variables. It is colorful, have better history management. And the thing I like most is you can run basic Unix shell commands like lscp mvrm directly on the Ipython command line. Well, to install Ipython, you first need to install pip using sudo apt-get install python-pip. Well, this pip is a Python installer and make installation of Python related tool easy. I think we have already the latest version. Yes, we have 9.01. Fine. Let us install Ipython now using pip sudo pip install Ipython. And well, this is again says requirement already satisfied. I have already installed it. So let us now run the Ipython interpreter. Let me clear screen and run Ipython. And there you go. Well, to get a quick overview of Ipython feature, press question mark, press enter. Do read this. This is a great page. Dear students, actually what I wanted to do was to install pun tools, which is an exploit development library written in Python. We are done with the prerequisites. Now let me do exit. Sorry. And install pun tools. Sudo pip install pun tools. Well, these are also installed. Let us now see how we can generate shellcode using puntools, and let us start Ipython again. And I'm using its interactive mode because I think it will be easy to learn in this interactive mode as compared to the non-interactive or script mode. Let me use a clear screen because this is a Unix shell command and I can use this in Ipython. Okay. The first thing we need to do is to import the puntools from pwn import, and let us set the architecture to AMD 64. Context.arch is equal to AMD 64. You can set it as per your own. And let me set the OS to Linux. Context.os is equal to Linux. Now I don't have to mention these in every command. Well, this is a very common task that a hacker mostly need is to generate a cyclic pattern. You can get help on different functions like cyclic. Well, this is going to generate a Objdump string. Let's check this out. Print cyclic, and let me give the length to 100 only. So this has generated a cyclic string, and let me search for this substring. I just want to get the offset of this. Print cyclic. You see the auto completion underscore find, and let me paste this BAAA over here. Well, it is apparent that its offset is 4, but let me confirm it. Okay, we will use it in next session. Too much. Well, to assemble your assembly code as well, you can simply invoke the ASM function on the code to assemble. For example, ASM, let me assemble the assembly instruction move RAX, 0. So you see this is the machine opcode for this assembly instruction for the mentioned architecture and OS. Let me check for another instruction XOR RAX having the same impact, and you see this is the instruction and no null bytes over here. Well, dear students, if you want to disassemble some machine code, you can use disasm. Let me use it, disasm, and let me copy this code. Copy it and just paste it over here, and you see this is the disassembly. So that is great again. Well, the actual task we wanted to do is to generate a shellcode, and for this we need to use the shellcraft submodule of puntools. Let me use that. Let me say, let's suppose shell underscore code 1 is equal to ASM and shellcraft dot, let me write down a command, echo Arif, but fine, the shellcode has gone in this variable. Let me add something up to this by using a plus sign over here, and let me use the exit call this time with a value of 0. Now the shellcode of these two instructions are there in this shellcode. Let's see the disassembly of this shellcode. Print this as some shell underscore code 1, and there you go. So you have two syscalls. This syscall is for write, and this syscall is for exit. Let's see the shellcode. Print, and that is there in the variable shed underscore code 1, and this is there in non-printable characters. Let me show you in this in hex encoding. dot encode in hex, and there you go. You have the hex code, and this is of course the Python way of writing shellcode. You don't have the \x before them. Let us now generate a shellcode for a basic shell program, and you see how easy it is. Shell underscore code 2 is equal to ASM shellcraft, and let me use the function sh. So let me print it, shellcode 2, and let me encode it in hex, and there you go. So this is a shell code for a basic shell. Just copy it and use it. Let us now generate shell code for a TCP bind shell as well. Shell underscore code 3 is equal to ASM shellcraft dot bind sh, and to bind sh we need to pass some arguments. If you are not clear about them, you can always use help on shellcraft dot bind sh. Let me use 54154 as the port, and let me use the IPv4. You can use IPv6 as well, and there you go. Let me use print again shellcode 3, and let me encode it again to have printable characters on screen, and there you go. So you have seen how easy it is to generate shell codes of your own. Well, dear students, this is a very vast domain. If you are interested, please do a scuba diving and see what all pun tools have to offer you in this area. And do not do it without the scuba tags. And meanwhile, let me fall back to slides again. Okay, so this is the last way of generating shell codes that we are going to discuss today, and that is Metasploit Framework's msfvenom module. Well, dear students, Metasploit Framework is an open source pen testing framework used for vulnerability research, writing, testing, and using exploit codes, and shell development. This MSF framework comes pre-installed with Kali, and today our main concern is about shell code, so we are going to use its submodule msfvenom to generate predefined shell codes suitable for many platforms and architectures. Well, dear students, msfvenom is a combination of msf payload and msf encode, putting both of these tools into a single framework instance. Additional benefits of using msfvenom are avoiding the bad characters and generating the shellcode in various file formats to be used with C, Python, C#, or maybe Java. Well, do dig out another module of MSF, Meterpreter, which is a post-exploitation tool and is used for in-memory DLL or shared object injection in the memory space of the exploited process, and that too without having to create a new process. Meanwhile, let us move on to the Linux terminal and see the proof of this concept. Let me clear screen first, and let me do msfvenom -h. -h option display you a bit of help about its usage. Well, these are the different options that you can use. It is a standalone payload generator, replacement of MSF payload and MSF encode. You can do a man of MSF venom as well. Let us see the list of the available payloads. MSF venom -l payloads. So it will display you a long list of payloads for different platforms. Maybe it will take a bit of time because there is a huge archive which it is getting information from for Windows, for different architectures. Since our architecture is Linux, so let me grab Linux and that to x86. We'll have a shorter list this time. Come on, must not take that much time. Okay, so this is a comparatively shorter list. Let's find out one. Let's find the first one. Linux x86 adds user. This is going to create a new user with UID of 0. Let's create the shellcode for this. Let me copy this and move ahead. Well, dear students, msfvenom -p and the payload is this one. Well, we can generate this with the default setting, but remember, different payloads come with different options. For example, for this user add payload, at least you must give it a username and a password. To check out options for the payload that you want to use, you just have to mention this payload hyphen options. So this will display you the options for this particular payload, and these are the options. So there are some basic options and some advanced, and the basic options, there are two required, that is the pass and the user, that is the password and the username. And the current settings are both are set to exploit, metasploit. So the username is metasploit and the password is also metasploit. So let me clear screen and let me now actually do that for you. Let me mention the pass to, let's suppose 1 2 3, and let me set the user to white hacker. Okay, and let me mention the file format to C. There can be different other file formats as well. You can mention Python over here to generate the code for Python. Right now we have generated the shell code for to be used in the C file. So once this code will be executed, it will create a user with the name of white hacker, password 1 2 3. And if I use here, let's suppose Python, it will generate the same shell code that can be used in a Python file. And you can use Java or C# and so on. Well, one more thing to avoid is that is to, you should not have null bytes over here. It doesn't, yes, we have a null byte over here. You see, these are the null bytes. These null bytes should not be there. And moreover, we need to avoid antivirus signature detection as well. And for that, you can use some encoder. And there are a lot of encoders available. Let us get a list of the encoders. msfvenom -l encoders. Well, one of the excellent encoder I often use for x86 is this Shikata-ganai. Let us copy its name, Shikata-ganai, and use it in generating the shellcode. Let me use the previous command and mention it, the encoder now with the -e option, and mention the encoder name, and let me mention the null bytes that needs to be avoided. I can avoid whatever character I want to avoid in the shellcode. Okay, so there you go. You have this, and now you don't see any null byte over here. I don't see any null byte. You can have multiple iteration of the encoder to over ensure thing, and let me say to have 5 iteration -i5, and this may increase the size of our shell code, which is right now is 610 bytes. And it has done the iteration or not. One iteration. Okay, fine. 610 bytes. Payload size is 1 to 5. Let me clear screen and let me show you the history of the commands that we have used. So these are the commands that I have used. Well, dear students, in this similar fashion, you can generate shell codes for a simple login shell, or TCP bind shell, or reverse TCP shell. I think that is enough for msfvenom. Other details you can dig out if you have a strong foundation. Let us fall back to the slides again. Okay, so that is the end of the session. Next session will probably the last one on this topic, in which we will use these shell codes against programs running on same or maybe remote machine having a stack-based buffer overflow vulnerability. And I hope, dear students, today's session was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. Wish you all the best, happy learning, and Allah Hafiz.